Hi everyone, and this video is a part of LeetCode Daily Challenge. Today is January 10, 2025, and we have a medium level problem. So the problem is saying that we are given two array of strings, words 1 and words 2. A string A from words 1 is universal if for every string B in words 2, B is a subset of A. And here the definition of subset is a bit different. So please read that definition. A string B is a subset of string A if every letter of B occurs in A, including multiplicity. So there is no problem of ordering. Okay, like in general, when we have subsets, we are also uh, we also take ordering into account. Like WRR should occur in the same way. It shouldn't be like RWR or RRW. But in this problem, that is fine. The ordering can be anything. But yes, you have to take care of multiplicity. Like if there are two R's, then those two R's should be present in the original set. So the time constraints are a little bit big. Like words 1 dot length and words 2 dot length is 10 to the power 4. So we need to write an O of n solution. Now suppose we take the first example to understand how we are going to do it. So you need to find out all the words, all the universal words. Okay, how are you going to do that? So first thing is that all of the words of words 2 are present in that universal word. Like they all should be the subset of universal word. So if suppose we take LeetCode and we need to check if both of these strings L and E are both present in LeetCode or not. See, L is present in LeetCode and E is also present in LeetCode. So LeetCode is a universal word. Similarly, if we check for Google, L is present in Google and E is also present in Google. So Google is a universal word. For Facebook, L is not present, only E is present. So it is not a universal word. In case of Apple, L and E both are present. So Apple is a universal word. In case of Amazon, neither L is present nor E is present. So we get Apple, Google and LeetCode as the answer. Okay. Now this example is a little bit easy because the strings are of single characters. If there were two characters, EE. Now see, is LeetCode a universal word? Yes. L is present in LeetCode and double E is also present in LeetCode. Is Google a universal word? No. Because Google has L is present in Google, but E is not present. Now, if Google has some other E as well, like something like this, if this was the spelling of Google, then it can be universal word because it has one L and it has two E. But right now it has only one E, so it is not a universal word. Similarly, for Facebook, there is no L, so it is not a universal word. For Apple, there is one L and one E, but there are no two E's, so Apple is not a universal word. So for this example, only LeetCode is a universal word. So how can you do this problem? See, we want that every character, every string in words 2 should be a subset. So for each character, with each character I mean like the characters are from A to Z. So for each of those characters, I will find that what is the maximum frequency of that character. Like suppose I'm talking about A, and I'll check all the words in words 2 array and check that what's the frequency of A in all those words. Like in the first word of words 2, the frequency of A is 1. In the second word is it is 2. In the third word is it is 3. Then in the fourth word it is again 1. So we will find the maximum one. So in this case we have 3 as the maximum one. Now we will check the words in words 1, that if any of the words have a frequency with have frequency of a greater than or equal to 3, then we consider that yes, a is part of that word. Then this word can be a universal word if it satisfy all other characters as well apart from a. Like for a it is satisfying, for b also it satisfies, for c also it satisfies, for all the characters, then it can be a universal word. If the frequency of a in that word is less than 3, then it's possible that it won't be a universal word. So how are you going to code this solution? So first, for all the 26 characters, we need to find their maximum frequency in the words 2 array. So you calculate the sizes of these arrays, and you will traverse for each character, and you will pick the word in the words 2 array. Then for every word, for every character of that word, if c is equal to ch, you will count it. Like suppose we start with a. Now for every word in word 2, we will count the frequency of a. Okay, so from here we will start counting in the first word, in the second word, in the third word, and we will update a frequency array with that count, with the maximum count. Okay, so frec of a will have the maximum number of times the a has occurred in some word of words 2. Okay, you can initialize this array as well. Its size will be 26 because there are 26 characters, and we have mapped the indices with characters. Okay, so we have calculated the uh, maximum frequency of each character in in words 2, of whatever words are occurring in words 2. Now we will traverse the words of words 1, and for its and we'll check like do these characters satisfy the condition for the word in words 1 to be a universal word. So how are we going to do this? We'll check for every character in words 1 as well. If ch equal to c, not c, we will count here as well. So it's something like this. Like first we will count the frequency of a in words 1 word. Okay, so if c is equal to ch, then we will count it. Doing this, if we are considering character a, we have picked a word from words 1 and we have counted it how many a's are present in that word. Okay, now if the frequency of this character a is less than, I mean is greater than count. What does this mean? The array frequency has frequency of uh, related to words 2. So in words 2, a word has uh, a word has 3 A's, but in words 1 the word has only 2 A's. So the word in words 1 will not be a universal word. So in this case, a solution will become false, and you can take a variable solution, and if the solution become false, then this word cannot be a universal word. So we'll break the loop. If solution is true, then you will push back that word in a result, and we'll return the result. You can initialize the result vector. Okay. Okay, I have made some mistake with this size. And we'll submit it. I think it should get submitted. Okay, this is submitted. Regarding the time complexity, this loop will only run 26 times. So its time complexity is O of 1. And this will run O of m times. So till here we can say the time complexity will be 26m. And yes, also each word's length as well. So I could say uh, consider this array length to be n. Okay, and this each word length is om. So here it will be O of m. So till here the time complexity will be nm. Similarly here as well, this array length can be n and each word's length can be m. So here also it will be n into 26 into m. So the overall time complexity will be O of nm. And you know that n can be at most 10 to the power 4 and m can be at most 10. So overall time complexity will be 10. Number of instructions will be 10 to the power 5 at most. So this solution will pass. So thank you for watching this video. I hope you like it, and please subscribe my channel and hit the bell icon to receive the notifications. Thank you.